The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
No, I wasn't.
I could tell.
Simple.
I could tell.
Because
I was looking at the chat thing.
Well, what I'm saying is I haven't been looking at E2 and E3 shit for a while, so I couldn't remember on what I had to put in there. So when I did finally get the way that I thought it was supposed to be, I didn't do the DDF, and then it worked. Don't fucking talk shit. Don't talk shit.
Let's have Daddy come over there and finish it. Those fucking memes are so funny.
What mean? I didn't even see
what
memes.
He knows that you're trying to get somebody to do something, and it says, just tell them you need Daddy to come over there and finish it, or show you how to do it. Piss off every blue collar worker there is.
That's amazing. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. Sorry, I had food stuck in my gullet because I was trying to eat a sandwich really quick before we started podcasting. How was your week?
A little stressful in the beginning. Had a CO2 rack just absolutely crashing. It's been doing it for a little while and ended up being like a obscure, screwed up thing that you wouldn't see unless it was like super duper cold.
Which is when it was.
Yeah. No, in the course, it was on a roof. We had a store that was crashing and flooding out the rack constantly. Like it would constantly flood out, mostly in the mornings and then late afternoons. It was constantly flooding out. Started looking at it on Saturday a little bit remotely and then had to leave to go somewhere. And then on Monday, I ended up going there after they were there multiple times on it.
Yeah.
And so what was happening is we were making a boatload of subcooling on the gas cooler, and our high pressure valve was opening to the max, which was 80%, trying to get rid of all the subcooling in the gas cooler. And what it was doing was it was actually over pressurizing the receiver to a point where it was spinning up the entire rack. So all 5 medium temp pumps would come on because it was that loaded up in the flash tank, and it was picking up liquid from the flash tank and having carry over to the compressors and eventually washing the oil out because of low superheat. And then it was compounding the thing because, I mean, as the compressors came on, the pressure increased and the subcooling increased because the pressure was increasing, but our temperature was staying relatively steady. And we had pretty much hardly any fan run, maybe 5% every once in a while, 10% every once in a while, but it was mostly just from prevailing winds. So we were making like a constant, like 26 degrees of subcooling. And the iPro was freaking out, trying to get rid of it. And the set point was 5. And ultimately the fix ended up being, it was a floating set point for the iPro. They ended up floating the
vertical or horizontal flash tank?
It's a horizontal, which it wouldn't have been a problem if it was a vertical. Yeah, with a horizontal, you only have in this flash tank with you running like a 15% liquid level, you only have 12 inches. 12 to 14 inches from the flash tank pickup.
So when I was envisioning this, and so my bad for not asking, because you and I were talking about this for a while. I was thinking, there was so much velocity, it was just sailing this and like carrying it up. But now that makes more sense. So it was horizontal. So like a lot of volume going in there was just literally just like up there because it was didn't have that much open space.
Correct. So it doesn't have the open space that you would normally have in a vertical. So this particular rack, if it opens more than 80%, it'll wash out the rack. So they have it as 80%. Can't go any higher than that. But it was randomly. Still don't understand why it was switching to pressure control randomly. I have a feeling it had something to do with it. It was so high as subcooling, and it was trying to get rid of it. And I don't know if it was going to some kind of fault internally inside the program, but the iPro would randomly switch to like pressure control, like 625, which was like the minimum pressure for the drop leg, but it just kept doing it. And then, but once we got the subcooling set point assigned to it and changed it from 5 to 20, and then it was on a sliding scale. So as it warmed up, it was changing the subcooling set point. It instantly stopped the rack. The thing just went like downward trend and then just popped back up and was running like 20% on the HPV and 30% on the BGV and 2 compressors. It literally just like you could snap your fingers and the thing just stopped having issues.
So weird. Yeah. You were showing me pictures and I'm like, I couldn't understand why, because I've only ever seen the iPro go to a pressure control if it goes to whatever, if it goes to its minimum, because it acts like a holdback valve if the pressure gets too low, because we want to try to keep that pressure up enough that we got enough pressure to feed into the flash gas. So we have our differential and blah, blah, blah. So I'd seen that when it went down to 624. The only time I've ever seen that is typically happens when you have a fan fault. Right. So all the analog output, let's just say you lose the signal and now the gas cooler fans stay on 100%, then I could see it happening because it's going to act like a holdback valve. But the fact that it was going into 624, 625, whatever it was, when it shouldn't have, even though the pressure was 700, you showed me a video where like I saw it fucking happen and I just don't understand why I was doing it. Did you ever send an email over to the people and ask why?
No, I didn't have a chance.
Curious, because it shouldn't have been doing that. That's the only time they should be doing that is if the flash tank, or I'm sorry, if the gas cooler pressure gets that low where it starts going to hold back. But yeah, like I said, I didn't realize it was a vertical, or I'm sorry, damn it, I can never get that right. Horizontal, laying down. I didn't realize it was a horizontal flash tank. Was that a ZZ rack?
Yeah, it was.
Gotcha.
Yeah, no, it was a ZZ rack. Yeah, no, it was a ZZ rack, and it's just a weird situation, but it caused a lot of issues.
Yeah.
And
did you ask New Andre?
No.
Okay.
We talked about it briefly. I don't have time to ask like 97 people, Brett.
Then I'm gonna ask 97.
I was on to like 3 other disasters after that. They got that going, and then I had to go do my CMRC conversions.
Gotcha. You want to talk about that briefly, and then we'll get on to what we're going?
Yeah.
Your VFD was broken, right?
No, my VFD was not broken.
No, it was broken. Apparently it was broken.
Constant 30 hertz all the time.
Okay.
No, we did a CMRC conversion on a Hill 2x2, which I'm pretty sold. If you're going to do those, leave the VFD compressor and do the second compressor, make it the CMRC. And basically, we end up having to throw a whole new compressor in there because I don't think they'll let you do a conversion on a transcritical compressor without buying a new compressor, which seems like they need to. Yeah, then somebody need to fix. So pain in the ass because we had to change the end bell on this thing for it to line up because everything was stainless inside here. So I got it out and I was like, "Oh, you got to be kidding me! I got to change the end bell." Because the old one was a 25 and a 30, and the suctions are on different ports. So the suction on the 30 comes in the top, and the 25 comes in the back. But it's all stainless. Yeah. We had to end up changing the end bell, and it was thicker. So, yeah, that was a bit of a treat, breaking 40 bolts loose on the back of the compressor.
It must have been fun to do the star pattern.
Yeah, star pattern.
You didn't know good nugget, did you? Jesus. You're supposed to do better.
Yeah, somebody else torqued it, not me. No, but we did the setup on there. It was actually pretty sweet, minus the fact that Hill gives you zero room to do the wiring, because the second compressor is with the VFD right on top of it.
Yeah.
So it's if you're gonna do one, I recommend you pre-wiring everything. I pre-wired everything onto whips on the CMRC and just labeled them and just ran it out the bottom of the CMRC panel and ran them out the bottom and then tied them in where I couldn't see them because I couldn't get my head in there to do all the wiring.
You have a big head. It's like a Rottweiler.
Yeah, okay.
What?
I hate you so much.
I know sometimes. Now I'm gonna have to look back at that now. So what strategy did you end up doing to try to control that big beast? Because what can CPC or Copeland do to do that?
Set up like a normal digital compressor. It's just getting a 0 to 10 volt signal and then set up like a normal digital, and it's just moving off of, instead of being 1 to 5, it's moving off of 0 to 10. So you set it up and then go through the Bitzer app or on the Bitzer Best on the computer. I think it's easier to do on the computer. But you got to have the converter, but go through and set it up, and it's pretty much just like a normal digital compressor, except it unloads both heads. So you get that versatility of unloading both heads. So you get to go down to 10% on a 2-head compressor. So that's a lot more unloading than 50% of a VFD compressor. Let's talk about what we're going to talk about.
All right, fine. All right. So we've done troubleshooting on compressors before, but we've never done like the troubleshooting on like utilizing the Bitzer app for transcritical and subcritical compressors. And you can't just put it in to the normal standard app or app for it, because what happens is it doesn't have a flash tank. It doesn't have all that other stuff. The liquid pressure is going to be whatever the saturated condensing was and all that other stuff. So we're going to go through that. So let me do that. So normally if you try to do a compressor, if I click on one of these compressors and I go to refrigeration and I go to 744 and I do transcritical, see how it just gives you the saturated condensing temperature up there at what would be considered the gas cooler at 75. It doesn't have a flash tank or anything like that. And your compressors are obviously going to act differently. So you can't really utilize this. So what you have to do is go to Bitzer software again. And when this finally comes up, you go to CO2 systems. And this is where you put everything in. Normally, you would just select what compressors that you have in here. And we're not going to do that. We're just going to basically do it off of a load and let it self-calculate. So let's just do the standard, negative 20, negative 22. What do you want to do?
Whatever. Just pick one.
All right, negative 20. We'll do evaporator superheat because this side right here is the low temp. We'll do evaporator superheat at 10 because that's what they're typically set. A lot of the case controllers are set for. Suction line superheat, we got to make sure we have at least 36 degrees of superheat rolling back to this compressor on the subcritical compressor. So I'm going to add, 26. All right, and then we have one that's set for 18 degrees saturation, 10 degrees of superheat, and then 10 degrees of additional, which would give us our 20 degrees of superheat that we need for our TC side. What you would typically do is the gas cooler outlet, you're going to move that to whatever it's currently running. When someone engineers it, you'll a lot of times on the refrigeration schedules, you'll see it was designed for an 85-degree gas cooler outlet temperature. And so that's where it runs at, where it's supposed to be at its max. So I'm just going to do 85 because I see a lot of racks now sized for that. And then for the flash tank pressure, this one's in PSIA, absolute. So we have to add 14.5. So I'm going to do 520. So that'll bring us a flash tank temperature of about 34 degrees, just about. You can select also if it's utilizing a heat exchanger off of the flash gas, which it sucks because the Bitzer app doesn't do, usually it's the whole suction that they're doing on the medium temp. On this one, they're just doing the flash tank. So I'm just going to get rid of that for right now. But I am going to add a heat exchanger for the low temp right here.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Can only do, I think 2.8 degrees, I think, for the max for this. And that's temperature drop, I believe. And we're just going to do this 60 hertz, and you see it already populated some compressors. So here you can actually then go back. Once you have all this stuff in here, you could select what compressors that you actually have, right? It did it off the size of what I had labeled here, which is 150 and 400. So it auto-populated. But what you can do is once it does that, you can select what compressors you have in there. Now, if I hit the play button up here, because I have all the pertinent information there, bam. You can see right now, this is how the thing would actually run if it was running at its utmost max of what it should be. Now you can see here, we have the information for the low temp. So we have the compressor evaporator capacity, how far the hertz is allowed to go, the power input, the current, and the temperature. This is what's important for you because this will tell you if your compressor's running at what it should be. Excuse me. The liquid temperature is going to be whatever the liquid temperature is at the flash tank, so that's not going to change. And then that's going to be your discharge temperature coming off your compressors. Down here, you got even more information. You got compressor frequency of what it's doing. These are solid compressors for this one and this one. They're the only one that's the VFD is this one. You can see the gas cooler capacity. So this would tell you essentially your total heat rejection of these three compressors, also the load of your low temp compressors, as well as your current for all these, as well as your discharge temperature, and then your optimal pressure, which you should be running at. You can also see the mass flow through the whole entire unit. That would be the flow going through your high pressure valve. So with that, that's how you can basically size your high pressure valve through there. And then where's the other one? Where's the other one? Evaporator flow, gas cooler max. I just saw it. Oh, there we go. Flash gas mass flow. So you can see right now at all these pressures, we should be putting through 3,146 pounds per hour of refrigerant. Now, if we were to change something, you can see on the high side, if we were to change anything on the transcritical side, basically anything on this side, it's going to affect just the medium temp compressors. I don't think it's going to affect the low temp at all, and we can verify that here in a second. But let's just say we have a fan go bad on our gas cooler, and now all of a sudden we're not maintaining 85 degrees. Now we're maintaining 105, which is really hot. And we're gonna hit the play button. So two things happen. This did not change at all. Nothing on the low temp actually changed. Down here, the medium temp, our capacity for our available evaporator capacity went down. The gas cooler capacity, right about there, the mass flow, but you can see the current went up on all our compressors. And the other thing that went up is our amperage and also our discharge temperature. So this is how you essentially use the app for troubleshooting to see what basically the amperage should be. The other thing that went up, I believe, yeah, right here is the flash gas mass flow. Let me go backwards because I have no frame of reference right now. So I'm just going to take a snapshot of this so we can see side by side essentially what it did. So we have, this is at 105 degrees, and then I'm going to change this back to 85 and then hit calculate. So you can see side by side. See if I can move this over a little bit. Of course. Stupid. All right. So side by side, it's better. My desktop isn't horrible today. you can see that the compressor evaporator capacity actually went down. The evaporator mass flow went down. The ratio, the gas cooler capacity, the gas cooler mass flow, because it's not as cool, and then the power input, and then also the amperage. You can see the amperage went higher with the higher gas cooler temperature. Mass flow through the whole thing, so higher there. You can see our total superheat here and here. And you can see our discharge temperature. So we went from 202 running on the discharge on that lead 199 running on that lead compressor up to 250. You can see our pressure also will increase as well. We can also see the mass flow through the flash gas bypass valve also went up exponentially. So if you have a gas cooler fan go out, you're going to put more flow in through the BGV, which is going to go to the medium temp compressors. And essentially why it killed our evaporator capacity, because now we're shoving through a lot of capacity of our flash gas here into the medium temp compressors versus just going right as much as it was before when it was lower. And I've showed that we've talked about this before. So you can see we've talked before about flash gas tax, right? This little triangle here that you guys argued with me for days, that basically represents how much flash gas is unusable, right? The bigger this gap is, the more the BGV is going to have to open up. So you can see if I up that temperature back up to 105, you can see the triangle got way bigger, and that's why the mass flow through the BGV essentially went up. So if we designed it for 105 degrees, our flash gas bypass valve would have to be way bigger.
Yeah, the old double CCM 42s.
And that's a lot of times, like when they do that, it's going to hide a lot of the issues, because if it's able to reduce the pressure and we still have enough compressors to do it, then hey, we got enough compressors to do it.
That makes sense.
But yeah, what I was explained is that when you had your issue, besides the flood back, you were letting more capacity go through the BGV than what it was originally designed for, because the valve had a nominal probably percentage of what it was supposed to be running, around 30% or so. So when that thing opened up, 80% at its max, it was just letting copious amounts of pressure through there, and which threw the system off of its equilibrium of how it was originally supposed to be designed. Because typically, depending on how you design this thing, if we go back to running it at 85, you see the liquid quality line 10, 20, 30. So right now it's producing probably about 30% flash gas and about 70% liquid. So that means as you opened up the high pressure valve more and more, that means more of the percentage was going into the flash tank, which means it had to be expelled out somewhere. But that's why BGV was almost up to 100% on your stuff. But the reason why I was flooding back, obviously, was the reason that you talked about, where you have horizontal receiver where it was just flowing literally right through, probably so much velocity rolling through, it was just carrying that liquid directly in your medium temp suction.
Yeah, that's exactly what's happening. And it makes sense about the equilibrium thing. It's just, yeah. Now put it at 50 degree drop, like what's it do?
It's going to move that line over. So it actually creates less flash gas. So like we talked about, it has nothing to do with the flash gas. Essentially, the valve was supposed to be running at normal high pressure valve. What usually trails anywhere from, depending on how cold it is. It doesn't ever go any higher than that. You're basically, because remember, the high pressure valve is 100% of the mass flow. So it was just opening up to 100% of the mass flow, and the BGV just couldn't open up far enough to relieve that pressure.
Once the pressure got in there, and it was done.
Yeah, because it couldn't go up. Because when you sent me that one picture, it was like at 98% or something like that.
It was just sitting there and just drinking it like a straw.
Yeah, and it was a couple pounds. It wasn't close enough on the control to make it like shut down. So here
it was like 15, 20 pounds before it hit that.
Yeah, so I have a program that I can share. Because it should be identical to what you were seeing.
About that, yeah.
So if we share this one. So the set point for your flash tank was 520. And your pressure was all the way up to what in yours? It wasn't up to 600 or whatever. It was like 585 or something like that when you sent that picture, yeah?
Yep.
Yeah, and you can see high pressure set point is at 600. So it wasn't going to do jack all shit until the flash tank pressure got all the way up to 600. Now, if the max on the high pressure valve, like on this one, was set to 80.
Mine was set to 80%, so it wouldn't go any higher than 80.
But imagine if it wasn't. If it was
allowed, it was 100, it would have just went right to Jesus.
Yeah, but then what would have happened was it would have went right to 80, and then all of a sudden the flash tank pressure would have got high, and then it would have started slamming down the HPV. So you would have saw this the thing go open, shut, open, shut, open, shut. And this is why we keep talking about doing split, because you said that rack had gas cooler bypass.
Massive gas cooler, but it had gas cooler bypass, but we weren't getting cold enough for the gas cooler bypass to meet the conditions to start. I am thoroughly convinced gas cooler bypass is just a Band-Aid. Like
there are sometimes people use it. I was talking to one of the guys who has a rack up in a lab.
You want to make heat. If you want to make heat it works good for making heat for heat reclaim. It does.
Yes. But the other thing that they use it for is, like I was talking to Flagan up in Alaska, and basically they have gas cooler bypass on there because he was telling me it got down to negative 47. Which is like 100 pounds on CO2. It's something freaking ridiculous because they lose power up in certain areas. So basically the rack just stopped. Pressure went way down. And so they actually did two things. They did gas cooler bypass, and they did a thermostat on the flash tank, heater on the flash tank to try to bring that pressure up. Because even the gas cooler bypass wasn't enough. Because if I think about it, the high pressure valve is going to slam shut if your head pressure is that low. And so the only other way that it can go anywhere is through the gas cooler bypass, where it bypasses directly into there. But it goes before the high pressure valve. It doesn't go directly into the actual flash tank itself. If you bypass around the high pressure valve into the actual flash tank, I can see it working.
That's a whole rare thing, though. Like, that's cold where nobody wants to live.
Flagan does. Because he was complaining about it. I was like, you fucking moved up there. Because I remember it was like 3 or 4 years ago when he's like, yeah, I'm moving up to Alaska. I'm like, why?
Yeah, I hate it here. God, I couldn't imagine how Alaska seems nice in the summertime for 2 weeks. But no, I'm a firm believer in split. The 2 or 3 times I've seen split utilized in Canadian racks, it is just so much better control. We're just wasting money and time and resources and energy into something we've used for the last 50 years.
And like I said, I've only seen the U.S. manufacturers. The only one that I've seen so far is Advancer. Advancer uses it. I saw the first one ever that I saw up in person was that one. Canada's been doing it forever because they're a lot colder. But the theory still holds true.
Just as cold here as it is in Canada.
Oh, okay, where you're at, yeah.
It was -2 yesterday on Monday on the roof when I was on there trying to get the rack back going. We should stop putting racks on roofs and outside.
Have mechanical rooms.
Yeah, CO2 is with as much issues as there is, they need to be in mechanical rooms.
If we had split, there wouldn't be as much issue.
And the controller needs to be at the rack.
That's right. They don't do that for that anymore.
Yeah, awful.
At least, what they could do is at least run an Ethernet cable from downstairs up to that rack.
They don't want you getting on their internet. They don't want you unplugging it either. And your phone don't last worth a shit when it's -2 and you're trying to get on Connect Plus.
What do you mean -2? I saw 14.
It was -2 when I first got there.
Lies.
Yeah, okay. You would have been dead.
What are you talking about?
Yeah. Mr. Texas boy crying about how cold it was. It wasn't even cold.
It was just wait. So I screwed up and I scheduled a training for, I think, January in Columbus, Ohio. And they're both.
Ain't even that cold in Columbus, Ohio.
You get the lake effect snow bullshit.
Lake effect snow. We get dumped on with lake effect snow.
Whatever. But yeah,
so I drive in the snow too.
No, I didn't forget how to drive in the snow. Dickhead.
Like everybody else from Texas, snows like a quarter inch, and everybody's
it rains. It rains, and they don't know what to do. They lose their mind. But yeah, that's even, I don't know. I've always been taught it was 25 pounds away from the relief, and that should be straight. Have you seen it usually this low, 600?
Yeah, I generally set mine lower too.
Yeah,
I like a little more oomph there before it hits.
Okay, because I know some have they'll have the pre-relief set for 590, like on the LMP and the Husband racks as well.
I hate that pre-relief with a dying passion. They never work. They always hang up every time.
Yeah,
the pre-relief turns into the main relief real quick.
Gotcha. But yeah, so like I said, back to what we were originally talking about. Not that. As you can see, what happens the more the triangle prevails. So like now, where you had me put it to 50 degrees, you can see they go all the way down. Yeah, you can see the amount of flow going into the flash tank went down exponentially because we're creating way less flash gas. That was at 3,900 when it was 105. It was at 3,100 when it was at 85. And you can see how much less it's actually rolling just because it's, that triangle is really teeny tiny there. So we're not barely creating any flash gas. So the amount of flow going through there ain't shit.
Makes sense.
So I'm trying to think, what was it? Was there something else real quick? Because I didn't really show it, but when you look at the compressor capacity on the low temp, so this is at 50 degrees. So you can see the temperature 129. I'm sorry, that's the main temperature. 134, 127, 127. And you can see the amperage 4, 5.62, and 5.62. But then if I change this up to whatever, let's just do 85. It should not change because nothing really changed with the suction, and nothing really changed with the suction, and nothing changed with the liquid. It's still staying at whatever it was. So if we go back over to here, put that next to it, same net refrigeration gain, same percentages of ratio, kilowatt, amperage, everything stayed the same. Everything stayed the same because it has no effect on the high side of the system when we're messing with the discharge temperature. As long as we have enough capacity to still suck down all the discharge that it's putting in there, it shouldn't have changed.
That makes sense. And the low temp's fairly steady because it's all in the medium temp. Except for when the medium temp shuts down, then the low temp goes bye-bye.
Yeah, it does. Yeah, so if you're doing this off the get and you just want to know what your compressor is doing, just click on compressor model number. And then you obviously, usually depending on what kind of rack you have, sometimes you'll have
if you can't find it and you're looking on here, include former types.
So I don't think that this one actually has it. I think this actually has every single type, but if you're doing no, it doesn't really have a lot of them. Huh. Oh, wait, is that off capacity? No, it's not. Because you're right, because normally there's a blank out where it says include former compressor types, and I've had to do that. But on this one, it's just there's only these ones.
It's the only ones I want you to use.
Yeah. And like I said, if you have a compressor that has a VFD for your primary, you could slide that down to whatever it's supposed, whatever you want it to be, whatever it's the frequency actually running for. So if you select this compressor, I think it does the utmost max. But if your wiring and your contactor and your VFD wasn't rated for that, if it was only rated to go to 60, then you're going to stay at 60. That's something you have to take in consideration, that, just because the compressor has a capability to go up to 75 doesn't mean that the wiring, the contactor, and all the other shit, you'd have to look at the original build and see what frequency they're allotted that one to be at. Because you could have a Copeland compressor that the Copeland semi-hermetic without an oil pump I know for a fact can go up to 70 hertz. But if the rack wasn't designed to go up to 70 hertz, because as the pressures, as the hertz increases, also the amount of current is going to increase. And so if the wire is not rated for that, or the VFD is not rated for that, it's going to make something go by.
Yeah.
And then, like I said, the only other thing that I didn't do is if you have some sort of heat recovery, some kind of heat reclaim. So you can do the fluid temperatures, fluid in and out, specific heat, all the other stuff. And then you can see as we change things on here, it's adding and subtracting things there. So right there, when I click on that, it adds a heat reclaim onto there. Same thing with here. We have the flash gas heat exchanger, because we talked about how the flash gas bypass valve will sometimes create a little bit of liquid. And to mitigate that liquid, a lot of times they'll put a heat exchanger right. Yeah. The only thing that it doesn't do is some of the racks have a main suction heat exchanger that usually will do all the bits of all the suction going through here. And so this particular app does not do that. There are some other ones out there. I pay for this one from Denmark. It's not cheap. It's $800 a year, but it does every single type of configuration that I've ever had to just mess around with. The only other one that I couldn't figure out where the hell it was, because I couldn't figure out what it was adding, is when it says desuperheater.
So it's adding a pass into the gas cooler to desuperheat the low temp. Or it's adding a secondary.
Oh, there it is. That's okay. I didn't see that come up before. Yeah, so it's a heat exchanger. So it could be an air, like just a regular,
or some kind of DX.
Yeah, where it's just basically just running air across the pressure that's going in here. So you'd have to design it to what you were actually getting the temperature down to. So if the original temperature coming off here, we saw it was getting 124, 132 degrees off here, then you can size this accordingly to get that temperature down. So if I hit the play button now, I couldn't figure out what it was adding before. I was looking for solenoids. Yeah. So you got 125 going in and 82 going out, which what that's going to do is actually going to give you more evaporator capacity, because then you're not shoving so much of the total heat rejection from the discharge of our low temp directly into the S end of our medium temp here.
Makes sense.
Yeah. And then you can adjust the pressure to what you want it. You can before when you had me do 50 degrees on the gas cooler out, the only other thing that I didn't do at that point was change the pressure. So you had, what did you have, about 715 pounds or something like that on the discharge side, Kev?
Yeah, it was about that.
Dyslexic. 715, and watch, it doesn't like those numbers and it'll just fucking yell at me. What? The high pressure is lower than the critical pressure. Okay.
That's the point.
Let's see if it'll allow me to do it now. No, well, wait a minute. Condensing temperature. No, it changed stuff now. Why did it do that? Oh, yeah, because okay, so, yeah, 60, because that was your min on your fans, right? And liquid subcooling after condenser, we'll mark that up to 25 like you had. It's probably yell at us. That's not supposed to work that way. Oh, no, it did it. So
just like really weird looking rectangle.
Because it's dropping nothing but supercritical fluid down until it gets down to, you know what I mean, over on this side. See what it did. Oh, now I'm curious now, because I want to see what it did to, now that we changed it. There's the mass flow. Oh, what the hell? There's no flash gas flow through there. Because you're basically saying that you have no flash gas being created. But that's what you had, right? That's essentially
pure liquid. Yeah, it was all pure liquid. It's all pure liquid. There's no gas.
Yeah.
But it's trying to relieve the pressure, and then the pressure's just sucking on the liquid straw. Of death.
Yeah, it was. Yeah, so even if you moved it up a little bit to just 15 degrees of subcooling, and it went to 616. See, that looks a little bit more normal, because then you actually have a little bit of flash gas actually being created here.
Yeah, we didn't have any flash gas. We had a ton of flash gas load in the in the tank because it was just pushing pressure and liquid in.
Sweet. Yeah. So what did we learn? We learned that splitting is awesome, and it should be used in the States, and we still don't use it.
When the iPro does that, raises subcooling, makes the problem go away.
Don't have to worry about that unless you're in cold areas like Texas. Why are you so sleepy?
Dude, I don't know. I'm exhausted.
Sorry.
Mentally.
It's because you're sad HVACing. All right. On that note, we'll probably get going. Talk to you guys later.